Hello, Mr. Andy here. The second assembly we're going to do this week is a little hex key wrench set. You can see it up on the screen here. So you can see we have 9 keys here that we're going to produce, and we're actually only going to make one hex key, and we're going to use a design table to create all the various sizes. Do notice that the length and the distance across flats changes for each hex key. So we'll be controlling a couple dimensions. We have a revolved part here for the riveted axle that goes through there, some washers, and then this case, which we're actually going to create as a sheet metal part. So you get a chance to play a little bit with sheet metal here as we proceed. So again, the final output, always good to see where we're going to end up. Will be a C-size drawing with a couple of 2D views and an exploded assembly with balloon leaders and a bill of materials. And so this is where we're going to end up. I want to back up to the case and have you take a look at this first. And what we're going to do with the case is we're going to extrude it. We're going to turn it into a sheet metal part, then flatten it so we can put these notches in and cut them, and then fold it back up. The pin is a simple revolve, so draw half of this. Yes, you can get it right with just these 4 dimensions if you use relations properly. The washer should be the easiest thing you've done this year. And then we're going to do the hex key. The hex key is actually going to be a sweep. So we're going to take this hexagon profile and we're going to sweep it along this path to get the hex key. And then we're going to create a design table, actually in Excel, to control the dimensions for the various hex keys. So let's take a look at some of this here. Let me get that out of the way. All right, so let's start a new Solidworks part. And we're working in metric for this one. And we're going to go to a front view and start a sketch. And I'm just going to real quick draw up the shape of that. Like so. And let's get some dimensions on here. I'm going to go pretty fast. You should be able to do this kind of stuff without too much trouble. And then we're going to draw a couple angled lines in here. And I goofed that one up, so I'm going to have to get a tangent relation in there. And then we can do a dimension. So we can get this 120 millimeter or 120 degree for both of these. Let's trim that up. Oop. Undo. And there's the outward shape of our case. We're going to extrude that. 31 millimeters. Now we're going to apply a 10 millimeter fillet in here. So let's go to the fillet tool. You want to do this separately. It tells you that in your drawing notes, but make sure you read them. And we'll put a 10 millimeter fillet there and there. Doesn't work so well if you put that in the sketch. Okay, next step is to shell this out. So I'm not going to cut the holes yet. We're going to do a shell. So we'll click on the shell tool. You've used this before. The material thickness is 1 millimeter. and we're going to take out all of these faces. And finally that one, and we'll hit OK. So it kind of almost looks like a sheet metal part now, but it's not. Again, you have directions in your handout for this, but I'm going to show you how this works. I'm going to pick the bottom surface, and then I'm going to go to Insert, Sheet Metal, Bends. We're going to set the radius at 2 millimeters. Material thickness should be given already by the thickness of the part, and we're going to hit OK. There are no rips or anything to deal with, and now this is a sheet metal part. Well, let's get the holes in there, so we'll sketch, and let's go normal 2, and we'll do a couple circles here. Concentric to those outside edges. Let's dimension one of them, and they are 10 millimeters, and we'll just equal relate them. Should be fully defined. We'll cut that through all. Now we need to flatten this part out so that we can make the next 2 cuts. Again, I'll drag this over for just a second. The cuts take place in the flattened state. So let's get that out of the way. I have the sheet metal tab turned on right here. You can get that yourselves by just right-clicking, and you can turn on the sheet metal tab. So I've done that already. You can also just go to Insert, Sheet Metal each time to do these operations. I want to unfold, don't flatten. That does something very different from what we really need here. If you flatten it, put those in, and then unflatten it, they'll disappear. So we're going to unfold. The dialog box over here is asking me for a fixed face. I'm going to click the bottom. And then for bends, there's only 2 of them, and I'm going to click both of them and hit OK. And that flattens the part out. Now I can sketch on this surface. Let's go normal 2, and we'll draw a couple rectangles. We'll make these collinear. And we'll real quick get some dimensions in here. This is 20 wide, 8 millimeters, and from the edge to the top, 26. And finally, 65 millimeters over from the edge. Now we're going to cut these, and we cut a little differently when we're in sheet metal. So I'm going to do an extruded cut, and instead of giving a distance or anything, I'm just going to say link to thickness. Then you never have to give a distance for a cut or anything. Now technically it's through all, but in sheet metal we prefer to just link to thickness. And we'll hit OK. Okay, that puts those 2 cuts in there. Now we want to fold back up. So we're going to go to the sheet metal toolbar. We're going to fold and just pick both those bends and hit OK. And there is the finished case for you. Okay. All right, I'm going to close that case model. We don't need it anymore. And finally, I'm going to show you how to create one of the hex keys and put in the design table. So again, you can read the directions. I've given you a lot of verbiage here on how to get through this, but I just want you to see it. So we're going to create this part. So I'm going to go to the front plane on a new part file here and start a sketch. And I'm going to draw from the origin, and you'll see this in the pictures, a straight line. And then we'll do a tangent arc, loop around a bit, and then once again we'll do a line. and we'll follow that tangent witness line there. That should create a tangent relation for us. We're going to dimension this, so let's dimension. It's 100 long, and we have a 4 millimeter radius. It's going to be pretty tiny. I'm going to shrink that down and get this shrunk down like that. We're going to put an angle dimension in here. Oops. Let's try that again. If I'd hit the right button. There we go. Dimension tool. 45 degrees. Now, the one interesting thing is there's a 2-inch gap dimension here in the drawing. And there's no way for me to dimension that from here. If I try to put that dimension in, I get something like that. And that's not the 2 millimeters that we want. What we want is the 2 millimeters point to point here. And I did that on purpose just to show you kind of another drawing technique here. So let's get out of there. And I'm going to back this up a bit. Let's get out of the dimension tool. And I'm going to draw a center line. Like so. And hopefully they are collinear. Oh, it's tangent. That'll work. And now I'll put a dimension in for the length of that line at 2 millimeters. And that accomplishes my task there. All right. So I'm going to close that sketch. Now, I need to create a plane, and this is a real careful step. Read your directions. The plane has to be attached to this endpoint. Do not, when you create the plane, put a 100 millimeter dimension in there. Your part will fail when this line changes lengths. So we're going to go to Features, Reference Geometry, Plane Tool. So I'm going to pick the right plane here, and then I'm going to pick this point. No dimension, and hit OK. All right, we're going to sketch on that plane. Let's go normal 2. I'm going to draw a hexagon out here in space. And I'm going to first of all click an edge and make it vertical. And then I'm going to create a relation between those two pieces of geometry. And we can pierce. You may get a coincident option. That would also work. And then I'm going to place a dimension across here. And we'll just stick a number in there. Doesn't matter which size it is because the table is going to take care of that. All right. So now we have a sketch here of a hexagon and a sketch here of the path. And we're going to do a sweep. So we're going to come up here to Swept Boss. The profile is this sketch. The path is what it's looking for here, is this sketch, and it's going to just sweep that shape along that sketch. And we'll hit OK. All right, let's get planes out of the way here and take a look at this. Now, one other thing you'll notice here, I'll show you how to do this, is that I've changed the name of this dimension to say length, and I've changed the name of this dimension to say hex. The others don't really need to be changed because they're not going to be in the table here. But it'd be nice to change these two dimensions. So let me show you how to do that. And then we're going to do a design table here. So I'm going to just double click on Sketch 2 and click on that dimension. And let's see if I can do this outside of the sketch. And we're going to call that hex. And then we'll double click on Sketch 1, click on that dimension. I'm going to swipe that, and we're going to call that length. And hit OK. All right, we'll see if that works. So here's my part. It's all finished. You'd probably want to save right now in case you crash the drawing in this next step, but I'm not going to worry too much about it. We're going to insert table. There we are. Sorry, they've moved it. And then design table. We'll just start with a blank table. I'll hit OK. All right. So I'm going to hold my control key down. I'm going to press the wheel. I'm going to pull my mouse like this. I'm going to double click on sketch 1. It's not really what I want there. I'm going to double click on this dimension. And you can see length from sketch 1 came in. Let's click on sketch 2. I'm going to delete that and then double click on this dimension. And that popped in. And notice it brought in the values automatically. Now, in the row or column A, starting in cell 3 here, I'm going to give the part numbers. So it's 2mm key, 3mm key. Sometimes you can drag this and it'll automatically, it's not going to do that for us, so that's all right. 4mm key. I think you get the idea. I'm not going to do all of these. We'll leave it at that. And then in these columns, you just put in the proper numbers. So we'll say 60, 65. This works pretty slick. You can actually put equations in. Anything you can do in Excel, you can do in a in this spreadsheet. And then the 2mm key will of course be 2mm. 3. This one I can pull down now, and it should. Nope, it's not going to. All right, 4 and 5. All right. Once you have everything in there, click anywhere in the drawing space to get out. So we'll just click out here. If we've done everything right, it's going to tell us it created some configurations for me. And now we can go to Configuration Manager. And if I double click the 2mm key, it should get shorter and smaller. We'll double click the 3, the 4, and the 5. Okay. If you have an error in your table, you can click the plus mark up here and then just right click and edit the table. Takes you right back into Excel, and then you can make changes to the table here until you get it the way you want it. Do pay attention to case here in terms of the lowercase m's and the capital for key, because this will be showing up in the bill of materials. Okay, so that's how you produce the key. Finally, when you assemble this thing, turn on temporary axes, because there is a little axis here for this part, and you can mate the axes to get everything lined up. Okay. So the assembly requires temporary axes on to produce this feature. Good luck. This should get you most of the way through it. And as always, enjoy.